Hey guys, Brandon here. A little while back, somebody had left a comment on one of my videos asking about the fuels used for the production of electricity in Michigan and how that impacts the sort of green factor or the quote-unquote emissions from driving an electric vehicle in Michigan. Which is a very interesting point and topic as electric cars become more and more frequent, and certainly seems like they're going to be becoming more and more frequent. Question does arise is like, are the electric cars actually cleaner, or is it just a really long tailpipe like they say? So I started digging around trying to find data about the production of electricity in the US and specifically in the state of Michigan, and what the types of emissions are from that production, what percentages, and then it sort of just blossomed into this huge data collection project that basically I mostly did yesterday and gathered a ton of information about electric generation and the fuels used and the emissions produced across the whole United States. So it ended up into this huge spreadsheet, which I plan to make available. And the data that I got is all publicly available. I got it from the Energy Information Administration, but I couldn't find like this nice big spreadsheet of the information that I wanted, which was basically like, okay, for the US as a whole and for each state, what's the breakdown of how much energy was generated from this sector, this sector, this sector, and then what's the amount of emissions into there with that kind of production. And it was surprisingly difficult to, well, the information was there, but it wasn't in spreadsheet form. So I had to look at each state like differently. And so I ended up spending a ton of time manually making these giant spreadsheets of all this data so that I could sort of analyze it and compare my state, which currently is Michigan, to some other states in the US as a whole. So yeah, this has turned out to be a super interesting topic. So let's take a look at the generation of electricity in the United States. Okay, so first I want to show you one of the spreadsheets that I've created, which is here. So this is the 2015 annual. So this is total production for the entire year of 2015. Broken down on the top here according to the fuel used, coal, petrol liquids, petrol, coke, blah, blah, blah. And then down this way, according to regions of the US, such as New England, Mid-Atlantic, East, North, Central, which is where I am here in Michigan. And then further broken down into the respective states of those areas. And then here, all these numbers are in gigawatt hours. In the blue lined areas, these are totals for the regions for each category, and it goes all the way down, and then down here we have US totals for those categories. So before I get into some of the nitty gritty here, let's check out a chart of total US production. So this is the total US electricity generation in 2015 in gigawatt hours. So this is the number of gigawatt hours produced. Last year, which was 2015, for the entire year, this is a lot of, literally tons of fuel, hundreds of thousands of tons actually, and millions of gigawatt hours. So here's our legend here, but you can see there are several areas that are dominant. The first here is coal, with over 1.3 million gigawatt hours produced from coal in the US. Again, this is the total US for the entire year of 2015, and that comprised 33% of the total energy production. Next under that, only slightly below it in percentage, is natural gas with another 1.3 million gigawatt hours produced. The next biggest category is nuclear, which I have here in orange. And that was just, well, a little bit under 1 million gigawatt hours. And those are the three dominant gorillas. The next biggest, we start getting into the not so much renewable, but at least sustainable energy sources. specifically hydro, which comprised 6.1%, 250,000 gigawatt hours in 2015. And then next is wind, so I have blue for water and then green for wind. So those are significant, even though they're quite a bit smaller. And then once we get into photovoltaics, which is PV, here I have utility PV, which is 0.6% of the total production of 2015. And then this darker yellow, mustard yellow, is distributed photovoltaics, which is basically like homeowner rooftops, and it's distributed throughout the grid. It's not produced by a utility per se, but together those comprise just under 1%. Another significant category which I wasn't expecting was biomass, which includes like garbage and whatever, but also a significant source produced by burning wood. And I don't know if it's like waste wood, like wood chips and stuff from production, or if it's actually like, chop down trees in order to make electricity. Maybe they're farm trees if they do that. I don't know. But anyway, biomass comprised about 1.5%. So, and I'm not an expert in these fuels. For example, I don't even know what petroleum coke is. But these things are like super tiny components of the energy production. And like biomass, I don't know what the advantage is or disadvantages to using wood and burning stuff basically to make electricity. All right, so that's the U.S. As a whole. Let's go back to this sheet here. And let's do a little look into the respective regions and categories. So let's start with coal. Coal is, by a narrow margin, the biggest production fuel used in the U.S. Natural gas is slightly behind it. And you can see that some of the numbers in this category are bolded. Those are the leaders in each of these categories. So for example, in New England, the biggest user of coal is Massachusetts. In the mid-Atlantic, it's Pennsylvania. And you can see some of these states are like vastly higher in usage than others. And as we go down here, you'll notice that one state has the letters in red. That means that it's the top user of the entire US. And I'll make these sheets available. I think they actually turned out pretty well. They might be useful to some people, so I'll make them available this is in Google Docs, or it's a Google sheet. So, but I just want to orient you a little bit so that when you're looking through here, you can see that stuff. So just really quickly, yeah, the U.S. leader in coal consumption for electricity use is Texas at 121,000, and I think they're the leader by far. Yeah. Okay, and then petrol liquids, which I don't exactly know what that is. New York is the leader there. It's a pretty small percentage of actual use. I mean, if you look down here, the U.S. total for coal is about 1.4 million gigawatt hours per year, and the petrol liquids is only 17,000. So I kind of ignore these little ones. They're just kind of insignificant. Next biggest is natural gas, which is 1.3 million gigawatt hours, as we talked about. And again, Texas is the leader for that, producing 238,000 gigawatt hours in 2015 from natural gas. The leader for nuclear is Illinois. Obviously, you have to have a nuclear plant. Not all states do. And they are the leader in that. Not by a whole lot. You can see Pennsylvania is up there as well. South Carolina is about half that much, a little more than half. Hydro is interesting because it's extremely clean, can be done in a way that's very friendly to the environment, particularly as Elon Musk has mentioned, micro hydro plants. And yes, this is a cool one to track. The leader by a vast margin is Washington. One of the key things to remember here is you actually have to have water in order to do hydro. So a lot of states do not have water. So that is not their strong suit. Anyway, Washington leads up with 74,000 gigawatt hours produced by hydro. Wind, also a significant but small production. Let's see, who's the wind leader? Here in green. Again, Texas. So their third leading category with almost 45,000 gigawatt hours produced by wind, which is essentially completely emissions free, aside from maybe the dust that wind is already kicking up. Next we go into solar. So we have utility photovoltaics, utility scale solar thermal, which is basically using sunlight to heat something, which then heats water, which then runs a steam turbine to create electricity. An example of this would be the Ivanpah electric facility. I believe it's in Nevada, outside of Prim, Nevada, which I've driven by a couple times. And then distributed photovoltaics is like distributed throughout the grids, is how I think of it, and like on rooftops and community solar farms, that kind of stuff. So the leader by far in all of the photovoltaics is sunny California, which makes sense. You do have to have sun in order to be a leader in solar. So some other states that are prominent in it are Arizona, and let's see, my state, Michigan. Oh, they didn't have any utility PV in 2015. So interesting. North Carolina has it's quite small but significant for this category. All right, and then the solar thermal, which I was just talking about, California leads that, but Arizona and Nevada also have a small presence of that. Although interesting, Florida has just as much solar thermal production as Nevada does. All right, distributed solar. California is the leader. Let's see if there's anybody else to mention here who is on that level. New Jersey apparently has a significant representation there. Geothermal, again, the leader is California, with Nevada having a significant component, and that's about it for geothermal. Hawaii also has a small amount. They have a bit of an advantage of having some volcanoes nearby, if you can consider that an advantage. And then the last one that I've actually graphed out is biomass, with California taking the lead by a pretty good margin. Florida coming as close as possible. Maine also uses quite a bit. Now, as I show you these numbers, let's go back to Texas, because you can see that Texas is the leader in a number of areas. One known for quite a bit of emissions, and then one that's completely clean, which is wind. And so it's hard to compare state by state, because the population of New York and California states is quite different than, for example, Rhode Island. So, calculating the emissions and the overall generation from these sources is a little bit misleading. So I took all this data and then transferred it to a per capita analysis. So in this row, well, again, I have it laid out by regions and states, and then now I have the population here for each state. This is publicly available data. I think this is from a census in like 2012 or something, so I mean, there may be a few extra people now in these states. And then I took all those numbers and I recalculated them. I took the numbers and I divided it by the population of a state to get a per capita amount of production. And because this is a smaller number, this is now in megawatt hours per person. Previously we're in gigawatt hours. So let's go down. Let's see who the leader is per person for electric energy production of electricity. And that is Indiana. Actually, I'm sorry, that's the leader in that area. The actual leader is Wyoming by quite far. So total, tons of coal they don't use the most, but per person in Wyoming, and they don't have a there's less than 600,000 people in Wyoming. They use more coal per person to produce electricity. Or I should say, they produce more electricity per person from coal than any other state. Petrol liquids, very tiny, almost insignificant part of the electric production, but Hawaii leads that category. Petrol coke I didn't even put up there. Natural gas, Mississippi, I have the leader here is in blue. Mississippi leads the amount of electricity per capita produced by natural gas. And let's go back to Texas. They are sort of in the middle, low to middle areas per capita of how much energy they produce in these more polluting areas. Nuclear, I forget who that's kind of a surprise. Per capita, South Carolina makes more megawatt hours per person than any other state. I think the total leader was Indiana or Illinois. It was Illinois. And they are significantly less per capita of energy production. So this is pretty interesting. So let's look at hydro again. Washington, because they just generate so much hydroelectric power, they are still the leader on a absolute value as well as per capita. So that's pretty interesting. Wind, who wins the production per capita for wind? That is actually North Dakota. They don't have a huge population, but per person of their population, they generate quite a bit. And I know Kansas has a lot of wind farms because I've driven by them. And I guess Iowa does as well. So they both have quite a bit smaller but significant per capita production. Also Oklahoma, Wyoming, and I guess Oregon has a little bit. But that's not too surprising. These are fairly windy states. Hopefully Illinois will get up there. I mean, they have the windy city, so you'd think they'd kind of get on board with that. All right, moving on to utility photovoltaics. Per capita, Nevada leads with that. And if you compare the populations in Nevada to California, which is where? Here. There's not much of a comparison, so it's kind of, per person they have a lot more sun in Nevada too. Okay, utility solar thermal. Arizona leads for that per capita, which isn't surprising given how hot it gets there. Shout out to Phoenix. And then distributed photovoltaics, the leader per capita is actually Hawaii, which actually kind of makes sense because they have a lot of sun and their electricity is also super expensive. So there are good incentives to do that. Geothermal is led by Nevada, again, hot state. So yeah, we'll let that go. Biomass, where's the leader for biomass? So up here, Maine. So per capita, Maine, which has a lot of forests and a lot of leads per capita for biomass production. So this is an interesting, another way to look at it, which I think gives a little bit more flavor because it's a little bit more fair, I guess, or intuitive to think of it as per capita. Yeah, so there we go. All right, let's move on. So after I had assembled the data of like production, this doesn't necessarily tell us like who pollutes the most, and I don't want that to be like a negative connotation to certain states. I'm not trying to make statements like that, but just there's other variables. For example, some states produce more electricity than others, and some states import electricity from others, so it gets a little complicated in that area. Also, coal has different grades of cleanness, and I don't remember the terms that they use for that, but there's like clean coal and dirty coal. So there's all kinds of confounding factors. But another element of so there's all sorts of other confounding factors, but there's another data element available on the EIA.gov site that breaks down per state the amount of emissions they produce generating electric energy. So here again is this. So this is a table of emissions, and then on this side I've got all the states again and the regions, by regions, and then I've got the pollutant. These are the three pollutants: sulfur dioxide, nitrogen oxide, and carbon dioxide. And then this is in these units, so tons. And then these are those same compounds, but in pounds emitted per megawatt hour produced of electricity. So, and this brings up some interesting stuff. So first let's concentrate on, let me highlight these, the actual tonnage. And again, I have the same kind of, the bolded ones are the regional leaders, and then the colored ones are the national leaders. So for sulfur dioxide, Maine leads up New England, and on down. Let's see, Ohio is the national leader at 355,000 short tons of sulfur dioxide. And some other prominent states are Pennsylvania, Missouri, Florida, Kentucky, and Texas is just barely in second place. Yeah. Nitrogen dioxide, the national leader is Texas, 229,000 short tons produced. Other notable states for production of that element are Indiana, Pennsylvania. And then the next category of carbon dioxide, again, Texas is the leader nationally, and then there are some other notable states like Kentucky, Florida, Missouri, Indiana, and Pennsylvania. Again, Pennsylvania is kind of a leader in emissions in the mid-Atlantic area. Again, emissions, total emissions is a little bit misleading because the states are different sizes and different populations. So these three columns are a little bit more informative because it's per megawatt hour produced. So it's basically like how little emissions are you able to emit generating the same amount of electricity. So in this units, the national leader for sulfur dioxide emission per megawatt hour produced is Indiana. Some other regional leaders are Maine, Pennsylvania, Missouri, West Virginia, Kentucky, Arkansas, Colorado, but some of the absolute values is pretty small. Interestingly, Hawaii is actually pretty high. Okay, nitrogen oxide expression, the leader, interestingly, is District of Columbia per capita. Or I'm sorry, not per capita, per pounds a megawatt hour produced. Oh, and by the way, I forgot to mention this column, which says that this is the primary energy source for electric production in that state. So Indiana, the leader in sulfur dioxide per megawatt hour emissions, they're primarily coal. The leader of nitrogen oxide per megawatt hour is primarily natural gas. And then, carbon dioxide per megawatt hour, who is the highest? Wyoming, and they are primarily coal. So some of the differences here might be in the relative ratios of whether they're burning clean coal or dirty coal. I don't really know enough to know that. Yeah, and then who are some other notable states? Hawaii, who their primary source, even though they have a lot of solar, is petrol. And by the way, hopefully that will be changing soon. Solar City is supposed to be putting in a lot of, I think they're putting in the solar, but they're also putting in the battery storage. I think it's on Kauai. So they may in the next decade or so, Hawaii might be able to get off of fossil fuels more than any other state. So that'll be cool to watch. Okay, now for now over here I have that same Now over here in these two charts, I have that same information but graphed. So here's the carbon dioxide per megawatt hour produced. Each of the states is here, which you probably can't see too well. So this, you can check out this chart online. And that just gives you an idea of visually of who the high ones and who the low ones are. Same with nitrogen oxide and sulfur dioxide. And a chart in red and blue with the same kind of layout, all the states down here. All right, so let's move on to the whole reason I did all this, besides it was interesting, is to get to these areas. This is a very important column here. What this is an electric vehicle, carbon dioxide emitted, the pounds of carbon dioxide emitted per mile driven if you charge from the grid in that respective state. Now, just like gas vehicles have different MPG, miles per gallon, electric vehicles have different watt hours. Let me expand this a little bit. Watt hours per mile. I used an average of 350 watt hours per mile. Okay, 1.61 kilometers. Okay, so that's 217 watt hours per kilometer. And the reason I use this, I have driven several thousand miles this summer, and right now I am averaging just over 300 watt hours per mile in the Tesla, and that includes one cross-country trip during the summer using a lot of AC and hot weather and high freeway speeds, and that also includes all my commute miles here in town, which is basically city driving. So it's a pretty good mix of my summer, but in the winter I use quite a bit more. So this is a little bit arbitrary because it's specific to my weather pattern where I live. So this will be probably less in California, probably more in some other colder states. If there are states that are colder than Michigan, which there are. So anyway, I just have to explain that because you've got to start somewhere. And I think this is a good, this is very generous. And, I would rather err on the side of assuming a little bit extra watt hours consumed for the sake of an airtight argument in regards to the accusation that might arise that electric vehicles are actually still polluting. So I'm giving the benefit of the doubt to excessive energy use. And by the way, I drive my car normally. I don't if I want to go fast, I go fast and all that kind of stuff. I'm not trying to hypermile every time I drive. Okay, so now we have carbon dioxide in pounds per mile, and these are the relative amounts. So here in Michigan, where I am, 0.462 pound. Whoa, sorry about that. 0.462 pounds per mile driven. And let's see if we can find a high one. Here we go. 0.72. Actually, I didn't bold out the national leader. 0.72. This is a little bit higher. 0.73. Do you see any other higher? No. So, okay, so let's mark. Okay, I don't have the controls with me right now. But let's just mark that. Okay. All right, so that's my own internal calculation for CO2 released per mile. And again, that's per state. And now I want to compare that to the gas vehicles. And then I strung that out as different miles per gallon. So 25, 30, 35, 40. And some cars are approaching 45, Priuses and maybe a couple diesel ones. And according to the EPA, and I got this from their website, for every gallon of gasoline that is combusted, 887 grams of carbon dioxide is released. And if you and then I think there's like 463 point something grams per pound. So if you do the math,
you can come up with these equations. So obviously, like I said, different vehicles are going to have different miles per gallon. So I started with 25, and the reason I did that is because that's a generous miles per gallon in the same category as the Model S, which I drive. So this would, maybe a BMW i7 or an Audi, what would it be, A8 or something like that. They're powerful cars, luxury cars. They tend to have lower miles per gallon compared to like a Prius or something. So I started at 25 miles per gallon, and then I calculated this number is entirely through. So 0.78 pounds of CO2 is emitted per mile. And now we can compare that to this column, which is driving electrically. And you can see, so I use green blotches to indicate that where a gas vehicle would actually emit less. And you can see that there are no changes in color in this column, which means that in no state is a gas 25 miles per gallon vehicle cleaner emitting than driving electric. With a generous amount of electricity use. Again, charging from the grid. If you have your own solar panels and stuff, obviously it's a different situation. So let's move over to a 30 mile per hour car. And you can see in this column, we start seeing a few states where it's actually cleaner or just as clean in terms of CO2 emission to drive a 30 mile per hour gas car. And those would be, because of how dirty, I guess you would say, electric production is. So those states would be Indiana, Missouri, North Dakota, West Virginia, Kentucky, who else? Wyoming, and that's it. So just a smattering. Most states, it's still better to drive electric. Moving up to 35 miles per gallon, you can see there's a couple more, just several more states that now it's actually cleaner to drive a gas vehicle, which emits 0.560 pounds of CO2 per mile. 40 mile per gallon, again, a couple more. And then once you get into the 45 miles per gallon, you can see that there are regions of states, for example, here in the West North Central, where driving a 45 miles per gallon gas vehicle is actually cleaner than using grid-produced electricity in that state. And you can see that all of these are coal predominant. I suspect it has something to do with the quality of the coal and the amount of coal. And then there's a few smattering again, and also most of the mountain region, I should say, states as well. Again, rather coal predominant here, and you can see the hydro predominant, which is Idaho, natural gas predominant, which is Nevada. Essentially, no matter what car you're driving, it's cleaner to drive a large electric vehicle. And interestingly, for Hawaii, the grid electricity emissions are such that driving a high efficiency gas vehicle emits less per mile driven than a large electric vehicle. So obviously, if you get an electric vehicle that's insanely efficient, perhaps the i3, because of its super lightweight, super narrow tires and funny looks, gets better efficiency while driving. So that might shift this toward, it might shift these colored cells to the right, and so you'd have to drive a 50 mile per gallon vehicle. So I know that was pretty long, but there's a whole lot of data in those tables, which, by the way, I had to generate those tables all by hand. It was like super tedious, but I think they look pretty cool, and I found it very interesting and enlightening on the topic of U.S. Grid-generated electricity. And so I hope you did too. Look for a subsequent video where I make it a little bit more fun, shorter video, by the way. And I compare the emissions from driving electric using grid-generated
electricity among a couple of the US Tesla YouTubers. So that'll be kind of cool. Anyway, I hope you enjoyed this video, and I'll see you in the next one.